Good afternoon, everyone. My name is Mehmet, and I work at ICANN, DNS operations. We are going to talk about some DNS security today. We have some speakers. As I said, my name is Mehmet. I work for ICANN. Dr. Richard Lamb works at ICANN as well. And we have Sandy from Nominum. We have Ken Silva of VeriSign. And we have Dan Kaminsky from Recursion Ventures. Did I say that right? All right. So I'm going to actually have Dr. Richard Lamb of ICANN start and talk a little bit about DNSSec and this recent happenings. Please.
Okay, that works. Good. Hi, as Mehmet said, I'm Rick Lamb. I'm the program manager for DNSSec at ICANN. And well, first of all, I was told that this white shirt is just completely wrong, so I need to get rid of the white shirt.
Yeah.
I did have a suit. I was going to wear that at first, but
I think actually if the camera can zoom to show what he's wearing, it's the DS record for the DNSSec root.
That's the hash for the root key.
That's for the signed root as of July 15 live.
Anyway, well, back to the formal program. So you know, ICANN. I don't know if you guys know what ICANN does, but ICANN is involved in coordinating the unique identifiers of the internet. You know, make sure people don't pick the same domain name, the same IP address, stuff like that. You know, I think we do a pretty good job. But last July 15th. One of the biggest changes, as Vint Cerf, one of the fathers of the internet, has actually confirmed as saying, is that one of the biggest changes in the last 20 years happened. We actually signed the root of the DNS. So just to get an idea basically of how many people here, you know, so I don't waste your time, how many of you guys know about DNS? If I say DNS, what? Wonderful. Oh, my God. Oh, awesome. Okay, I can skip all this. All right. Anyway, you know, in our humble way, and this was a joint effort.
Again.
and this was a joint effort I need to make clear with VeriSign and Department of Commerce. But this is one of the times we've worked really well together in this and actually have created this signed root. Kind of a humble thing. It's really just generating one key at the top of a PKI, but we involved people from all over the world to bring into it because, well, of course, you know, who's going to say, trust me? So, we made sure we had 21 people involved in this. So far we haven't seen any problems. It's one of the things that's hard to convey about this humble event is that this has opened the door to a whole range of other applications and other things that people can do, because now we have this single source of trust. Time will only tell if it really is a single source of trust, if people start building their applications on it. But now we have this opportunity, so it is one of the biggest changes, and hopefully, I'm sure Dan will talk to this, but hopefully this will create the opportunity for people to create solutions for some of the things that have been plaguing the internet forever. I mean, there was a great line Jeff Moss gave at the Black Hat conference that said, what security have we really done? What have we really solved? What have we already created in the years of the Black Hat conferences? And not much, but here's one example. Here's a concrete example of something that can be used in the future. And so we're hoping this will work out fine. And later on, the questions and answers, please just ask me anything you want to know, me or Mehmet, about how the system was designed, how we generate the keys, and that whole process. That was something I was involved with. Thanks.
Yep. Thank you very much. Sandy?
Yeah, sure. Sandy Wilborn from Nominum. It is extremely interesting that we got the root signed. That's a huge thing. If people know anything about DNSSec, it's been kind of cynical in a way, because it's been 15 years that people, there were, I don't know, 2 or 3 designs of it that came out, and finally some people have agreed on it, but we're just at the start. Like, this root thing is a big deal, but it's just the start. I mean, .com won't be signed for till, I don't know, March of 11, right, Ken? And I think the cool thing about being here is I'd encourage people here to take a look at it, because we'd rather find out the problems sooner rather than later. So
break it now.
Break it now. There you go.
Ken?
Thanks for that, Sandy.
Hey, I'm out there on
I
the...
have to actually break it.
Yeah.
It might be broken. Without belaboring the DNSSec element too much, it is a pretty important milestone, and we get asked a lot, why did it take 15 years? And even at that, even after you decided on what the standard was going to be, why did it take so long to roll out? DNS is a pretty important part of the internet infrastructure, and it's an absolutely critical part. And I don't think anyone who was involved wanted to just sort of roll things out without understanding the impact that it would have on various pieces of network hardware. Throughout the years, network vendors, security vendors, firewall vendors, et cetera, have tried to add value to DNS packets as they come through the network. Load balancers, those sorts of things. That if something was on port 53 and it was purported to be DNS, then it could only be 512 bytes long, and that has changed. So we spent a lot of time really working with ISPs and working with various vendors, hardware and software vendors, to make sure that the subtle little things that in home routers and consumer routers, et cetera, didn't try to block those elements. Now, all of the pieces of DNSSec are not actually in place yet. While we've signed the root, and many top-level domains are beginning to sign there's still much more work to do, and Dan has done some work in this area. There still isn't a good way for the end user to actually see the benefits of DNSSec just yet, because all of the bells and whistles haven't been fully deployed down at the client level. So as those start to change and those start to become more visible to the consumer and to the end user, I think you'll see the benefits of DNSSec really start to take off, and adoption will begin to take off. We don't expect every name in the comm zone or the net zone or any zone for all that matter to be signed, or every delegation to be signed. But we do expect that as the tools become more prevalent and as it becomes easier and easier to adopt, that people will adopt it as a normal course of events. Now that may take another 10 years, or it may take 10 months for all we know, but we hope that it adopts quickly. We hope that the client-side tools begin to take off, and that DNS becomes an integral part of the infrastructure for not just passing domain name information and IP addresses, but for also passing other things, because now we have an infrastructure that is a trusted infrastructure from the top to the bottom. Is it going to solve all of the problems around the DNS system? Absolutely not. In fact, in some ways, it may actually create some interesting things from an infrastructure standpoint. But there are many other elements other than just the resolution of DNS, which are part of the DNS system. And while the last 2 years, I think we've focused a lot of attention on talking about the resolution piece, or the DNS servers themselves, the other elements still need some work, and that is the registration process, for example. You can make a change and then wind up signing that change. Someone could maliciously make a change and then sign that change and then push that out. And then we would have a bigger problem, because we actually trust that. With over 1,000 registrars that are registering .com domain names, there are a lot of points of failure there where the system could be compromised, and we're going to spend probably the next 2 years focusing on how we can tighten that down with multi-factor authentication and some things that we can do to help protect against social engineering. So, okay, so
Speak up, then.
So now that you didn't hear a single thing I said, I'm finished, and I'll hand it over to Dan.
Dan?
Man, I think I really understood what I was getting myself into. I'm Dan Kaminsky. You don't know me, I've been speaking here at DEFCON for quite some time. I'm Chief Scientist at Recursion Ventures. And about 18 months ago, I think I was like most engineers when I looked at DNSSec as way too much work for no obvious benefits. Yeah, it turned out I was wrong. This technology is awesome. For the last 18 months, I've basically said to anyone who's asked, wait, this root signing is going to change things. Like, this really, we're so used to all these technologies coming out and people hyping them and then being, whatever. No, this one's actually pretty cool. So we're releasing a name server. We're releasing a name server, and we're releasing a bunch of code pretty effectively here to do things like, how about we deploy DNSSec in 2 minutes? How about we get DNSSec support in every open SSL-based application by running a single command? What if you could get the browser lock immediately in Internet Explorer, in Firefox, and Chrome based on DNSSec, making self-signed certificates work and work securely? What if you could actually recognize email as signed and actually easily validate that signature? What if getting PGP keys was not such an utter pain? Wait a second. All of this is not just in theory. All of this is not just stuff we could do. It's stuff that we're able to do today. In security, we have made a tremendous amount of promises about how we think the world could work safely. And you may have noticed, or you may not have, but a lot of the code that's been supposed to work, been supposed to be helping us defend our networks, been supposed to be helping us fulfill our promises, yeah, that stuff doesn't work in the real world. It stops scaling real fast. This DNSSec stuff, DNS has been scaling like nothing else for 25 years. We'd be lucky to have security working that well. And it looks like we got pretty lucky.
Thank you, Dan. I would like to add something quick, and then we will move on to the questions. If you have questions, please move on to the mic that's located in that direction. This is DNSSec. Obviously is something that's been worked on by IETF, Internet Engineering Task Force, for many years. So everybody over there deserves a big applause and big acknowledgement about the fact that they have spent many years volunteering and working on this project. And they are the ones who made this technology come to the reality. This is one of those cool things that doesn't have an Apple logo, but still very cool, I believe. So it's a really cool technology. So I would like to move on to the questions. Any questions? Yes.
Okay. You're done.
No. I'm glad we get questions.
Is it my understanding that the signing key was split up and given to individuals so that in the event of a meltdown, it could be reconstructed?
I will have Dr. Lam explain that more clearly. That's a great question.
Thank you very much for asking that. Like anything like this that's high profile, and sometimes it gets sensationalized. What is split across 7 smart cards is the encryption key that is used to encrypt the private part of the root key. That encrypted private part of the root key is in another smart card that ICANN controls and has, of course, duplicates of, and we, backup copies of in various Class 5 GSA safes, that we have. So the idea is that you need 5 of, maybe I'm getting too much detail, stop if I'm getting too much, 5 of 7, of those cards to come together, and the encrypted copy of the KSK that's sitting on a card to recreate the private key inside a crypto device, a hardware security module inside a crypto device. And this is something that's only going to happen if all 4 crypto boxes on both coasts completely obliterate themselves. And I don't know. There's a earthquake on the West Coast and a nuclear explosion. In D.C. Actually, it's not quite in D.C. It's in Culpeper, Virginia. None of this is secret, by the way. It's all on the website. That's what they are. They're not. Those cards do not have pieces of the root key. Period.
So no elaborate Hollywood scheme of intercepting them all and making a duplicate and anything like that.
Well, I mean, you'd have to. That's why it's 5 of 7. I mean, you'd have to go across and at least get 5 of these guys and make duplicates of them. But they still would not have the root key. It's still got no value. But and the flip side of that is also that who's going to trust ICANN, right? So what we have, this encrypted version of the private key, we have no value. I mean, this is the standard, and I know you guys are very expert at this, but this is where we've tried to gain some security in this by doing this M-of-N scheme. Does that answer your question?
Yeah, thank you.
Okay.
Yeah, the idea behind that, I think, is sound, and that is that early on there was a lot of discussion